Hi, Katarina. Can you hear me?
Can you hear me now?
Yep, got ya.
Yeah, finally. Yeah, okay.
How am I sounding?
You're sounding very good as usual. You have a really nice voice, as
Yeah,
Paul Branson mentioned.
my presenter voice.
Late night DJ voice.
Yeah. I'm not sure how many attendees will actually end up signing up. We had about 70 registered, but there seems to be a lot from some of our overseas regions, so perhaps they're signing up to get the recording, but that's fine.
Mm-hmm. We already have
5 so far.
Attendees? Five,
Yeah.
5 attendees. You're already recording it. At least it's showing to me that you are recording.
Yeah, I think the moment that you start broadcasting your screen, it does record.
Okay.
Hopefully this topic is not too boring for you.
I can always learn. Digitizing open pit trail and BlastPad data. That's actually interesting.
I guess it's one of those things that, in my opinion, should be ubiquitous, but we often find ourselves going to operations and visiting sites, and there's still a good mix of conventional methods with paper and Excel as compared to new technologies that are available these days.
Yeah. It's probably very applicable to some areas. I would imagine somewhere in Indonesia, somewhere CIS region, that could be very, very valid point for them to actually transfer into new technology.
Yeah,
the
definitely.
First step is always very difficult, and people have hard time letting go of paper and Excel. So
hopefully one of those things that I do touch on today is just that idea, exactly that is, I don't think people have to do everything at one time. Definitely not. Drill and blast is a big process, so it's often worth just picking a good spot to start.
Yeah. Doing the first step, even if it's a small step, it's still better than just not doing anything. in terms of innovation and transformation of the business.
That's right. Drill and blast is a very, I guess it's a very iterative approach. It's a very agile type of process. You know, we do need to change what we think is worth changing based on analysis of previous, results, and make sure we iterate. It's not about reinventing the wheel in any sense.
And yeah, and everything really happens quickly for you. You have really, really short cycle. What will be your time between blasts typically?
Yeah, it really depends. Some operations blast once a day. Some blast maybe once every few days. If you're a sort of smaller operation, lower output, you might blast once a month.
Okay. But it's still, even if it's once a month, it's still a very, very short time frame to learn.
Definitely. Yeah.
Getting more people joining us from different regions.
Yeah, people are popping up. Again, yeah, based on some of the attendees, they may just be signing up for the recording, but that's okay. In context of, having a good discussion group, small is the better, right?
Of course it is.
Yeah. It'll make me feel less nervous if there's only a small handful of people.
Less nervous to start, and then once you start, you're going to be all right. It doesn't really matter how many people there.
My neighbor has some nice, lovely roses in her garden, so I've got my window, my blinds up, so I can just look at that and de-stress.
Is it raining in Melbourne or?
No, it's quite a lovely day actually. Slight breeze, sun's out.
Yeah, just nice to end the week with this weather, comparing to what was happening the last couple of months, probably a week and a half.
Torrential rain. So has that gone away now?
Yeah, it's really sunny and nice. Well, it was already sunny yesterday, but all this humidity from rain, started evaporating, so it was really difficult to breathe. But now it's really nice and breezy weather, so I think it's going to be awesome over the weekend.
Yeah.
Any questions?
Oh, we've got a question already. Good morning to you, Sushil. Thanks for joining us today. Not long to start. It's 3 o'clock now. I'll give maybe a couple more minutes and then we can get a start.
We got another question, Alfred, from
Yash. Can we get a recording of the session? Yeah, I think we'll just speak to our marketing manager. It probably will get uploaded somewhere on our website for you to have a viewing of later.
I'd say just give us some time with it. We will sort of organize a follow-up email with the recording once we get it ready.
Yeah, that's right. Well, we probably won't wait much longer. It's almost a couple minutes past, so we should get a good start on this.
Yep.
Okay, so hi everybody. Thank you for joining our Datamine webinar today. If you haven't met me before, if you didn't know, my name is Alfred Tsang. I am the product manager for our comprehensive open pit drill and blast solution, which is called Datablast. Joining me today is Katarina. Katarina is our product manager for Mindscape Geology and is definitely going to be a lot of use and help to me today to help answer and attend to some of your questions. So on that topic, if you'd like to ask anything today, please feel free to type your questions into the questions chat box. Some of you already found where that is, which is fantastic. The webinar today should go for about 30 to 35 minutes, depending on how fast I read. And I've got some time at the end to answer some of your questions if it comes up. So the topic of our webinar today is about digitizing your open pit drill and blast field data. To reach this objective can be a new journey for some people. While it may already be something you do in your operation, whatever stage you're in, hopefully some of the things I talk about gets you thinking about the digitization of drill and blast in your own work. Okay, so what's our mission here? Our mission is to help you insert your mind into the digital world with the use of Datablast, optimizing the whole drilling and blasting cycle from the palm of your hand. With so many digital tools these days at our disposal, I think that drill and blast can gain a lot of optimization through technology. That's one of my passions, and hopefully we can highlight some of the topics for you today. A little bit more housekeeping. So definitely, if you guys want to get in touch with me, here's my email and my LinkedIn. I am a mining engineer by background, so I have a passion for drill and blast. I've spent some time in the industry as a drill and blast engineer, and I also have a good passion for technology. So if you feel like just reaching out and having a chat about anything drill and blast and technology related, or just to say hello, please feel free. I'd be really keen to hear about some of your drill and blast stories as well. And I'm definitely happy to organize some personal demos for you if you're interested. So definitely please reach out. So let's begin. It could be just my opinion, but definitely is an experience as I have traveled around some different operations around the world to look at drill and blast in my role. But even now in 2021, drill and blast field teams are still using a lot of manual methods for data collection and data entry. It's a time-consuming process, which could lead to a lot of loss of crucial information, which has a lot of heavy implications. So today in our webinar, I'll give you an overview of some topics. So some common drill and blast problems that we probably see a little bit too often, and it should not happen anymore. How data collection in the field can help resolve some of these issues, how to utilize technology to streamline that data collection, and some strategies to shift your operation into the digital world. And I think that every operation is going to be unique in its own right, but definitely just to start talking about some topics like this is hopefully going to be useful to people. The drill and blast field data, what are we referring to first of all? There's a lot of different forms of drill and blast data that we can collect in reality. And what we're going to be focusing in on today is some of the very common ones that I think perhaps seem basic to some, but definitely has a lot of insights that it can unlock for your operation. So in the drilling phase, we could be talking about things like actual depth that's given by your drill machines or your drill operators measuring after they've drilled. If you have really kind surveyors and they go and get the GPS pickups of the actual drill collar locations, if you're lucky enough to have drill navigation systems and the GPS coordinates from that, actualized angle and bearing, if you have that in terms of readings from your kilometers on the drill machines themselves. That's some of the drill and blast field data that I'll be talking about. In terms of QA/QC or as we call it, measured data, usually what you do just before charging. Again, lots of different types. Really basic and common things could be your measured depth, the depth of the blast hole just before you load the actual hole, any presence of water. And it's definitely not limited to that. Depending on the operation, you may have a lot of requirements to measure things like temperature, mud, collect interesting flags about the hole, such as whether or not there was broken ground or you're sensing gas, anything like that. It is definitely all within that realm of QA/QC just before you're charging. And with charging specifically, it's definitely about the explosives, of course, but it's also about the explosive type, the products used, the actual position of your charging decks. It definitely is useful to have total explosives for a hole, but it definitely is incredibly more insightful to know where the charge was placed. So, digitization of your field data. It sounds like a really great thing for us to be able to do, but why would we do it? Well, first, let's go back a little bit and let's try and understand some of the problems that we face in drill and blast. Effective management of data is often the last thing that we think about in drill and blast. That's generally because drill and blast teams face a lot of intense production and safety pressures on the mine site, and I can attest to that myself. In drill and blast, we have a lot of burdens to take care of. We must not cause poor production rates from undesirable fragmentation, poor diggability. So I do separate those ideas because fragmentation is different from diggability in terms of how well rocks are fractured, but in terms of how swollen or how loose the material is, it's going to definitely affect your diggability. Resource dilution is a massive headache for some sites that have really difficult resources to recover. Uneven blasting benches is one of those things that is often overlooked, but can have devastating effects on your health and life of your machines, your operating machines like dump trucks and excavators and dozers, as well as the actual cycle times of your mining fleet. We must, on top of the sort of production pressures that we face, we must also try and improve on poor blast quality, which can often arise from incorrect things like drill conformance, poor blast hole quality, ineffective use of explosives. Drilling a hole is not just to put a hole in the ground, it is also to put a good hole in the ground. You could max out your RPM and pull down pressure on your drill machines to get a hole really fast, but what's the quality of the hole afterwards? And it's going to definitely have a big impact in the order of 10, 15, 20% of the amount of explosives that goes into a particular hole over your design. Ultimately, it's paramount in our duties to eliminate and effectively manage hazards such as fly rock, overpressure, vibration, misfires with every single blast. So these are all showstoppers. These are all things that if they do happen, we have the inspectors come out to site and stop us and make us review our processes. Worst case scenario, we get damaged equipment or even people. This is absolutely something that is paramount to control. So these are all the problems that we face. On top of that, as our roles in the drill and blast industry, as engineers, maintaining this steady output of design holes to drill and for loading explosives, it's very time consuming in itself. Being on the drill and blast team, there's also a reality that is unavoidable sometimes, which is that reconciliation and reporting. We have the responsibility to ensure that drill and blast operation is measured properly, just like with every other process in mining, and it's reported on. Sometimes the simplest metrics that operations tend to collect about drill and blast are just things like total drill meters, total explosive loaded, and blasted volume. And reconciling these points already is in itself time consuming. However, I do ask this question: could we learn more from collecting more data? And can we do this while we're still reducing the time spent on this very tedious task? Some of the problems, specific problems. Rectifying issues like big rocks, it's dangerous and it's time consuming. You may often need to get contract drills in to actually put holes into big boulders like this, or you might need to build up running surfaces so that you can access them with your own drill. Hopefully it's a rare occurrence for everybody, but when it happens, it's definitely something that you wish you had avoided. So in this particular circumstance, what can more field data do to help? So the causes for something like this could be varied. But one question I do ask in these situations, and potentially one of the causes, when we're designing the next pattern, are we sure we blasted the previous? That's a really fundamental thing to ask. We may know total explosives for the pattern, but do we know whether each hole is loaded? Are we making assumptions to design the next pattern based on just drill holes and not blasted holes? So we need to easily check if these holes have been loaded. Another common and simple metric in QA/QC is measuring depth and water, and these metrics can highlight a lot of potential issues before they arise. So I wonder, why doesn't every operation do this more consistently? On the left in the design picture, that's representing in the blue the target mining elevation. The yellow is representing our subdrill surface, and the holes that are displayed there is a representation of where the reality was for this particular blast in this operation that I visited. So taking into account the QA/QC depth of the holes, you can see the theoretical blast surface is already definitely higher than your subdrill position. So what chances were there of achieving a good even blast surface? Unfortunately, in this example, the data that was used to do the analysis was collected but wasn't checked until after blasting has occurred. So why could that be? So the question for everybody in this audience is this a common occurrence in your operation? Does it occur? I've definitely been guilty of causing some pretty shocking blasting running surfaces like this, and hopefully I've learned from it. And what's worse about these particular situations is it's another point of needing secondary blasting to reestablish your running surfaces. It's time consuming, it's costly, but there's no alternative. Sometimes your drill machines are limited by what the shape of these things are. Another problem, fly rock can happen easier than we think if we forget about our QA procedures. So how does more field data in this situation help? And obviously digitization of that field data to get it to us quicker. It's things like hole position, depth, charge location, charge type. It's going to highlight a potential for fly rock before you initiate it. If people here are unfamiliar with the empirical relationships between blast holes and fly rock potential, it's effectively a relationship of burden distance or depth of cover with the charge weight. So any deviations to your hole positions, choice of explosives can change the factors of safety that you were designated to use in this particular blast. You could have planned to use ANFO on the free face there, but due to some water issues or moisture conditions, the operators choose to use a emulsion blend product. Your charge weight immediately changes, and then therefore the factors of safety you considered were completely different. Hopefully this never happens at your operation. It's a bit of a stock image I took from the internet. This one's not from a client specifically, but that's a good thing. I can't find too many photos from operations that have this problem, but hopefully it's not one of yours. On the right-hand side is a design representation of where those holes are with your free face scan. And what you can see highlighted is a inadequate depth of cover. So a question with this world of digitization of field data, in the absence of it, do you consistently collect enough information to ensure you have the right QA procedures to prevent what happens on the left-hand side picture? Did I skip? I didn't skip. No, I didn't skip. So lots of problems, lots of different things. Hopefully they don't happen too often to us. But if we want to collect more information from the drill and blast field processes, how do we have the time to do so? It's my opinion that the old ways are definitely slowing us down. And so here is a typical process in getting our designs out to the field and recording the data coming back. So let me know in the questions and the chat box if this is a familiar process to you. We may often start with design hole layouts in some form of mine planning tool or an add-on to a mine planning tool, AutoCAD perhaps. Your designs, if you have designs, your designs then are exported, and more often than not, it's manipulated in Excel. I myself have created an abundance of Excel models for drill and blast in the various operations I've worked in. You'd often then have to print these all out for your field teams, for your drillers. They're going to drill the holes and write down onto these paper copies of drill logs and then bring back a stack of paper. Your QA/QC crews will write down their findings on blast hole logs and then bring that stack of paper back. If you're have enough time or your procedures are good enough, you'll definitely be using that information to update your charging requirements. But once they go out to your charge crews, same story. They go and charge the holes and bring back a stack of paper. So meanwhile, who's keeping a track of all the paper? If we're spending that much time in collecting it in the field with the operators doing that, why aren't we using more of it? Why isn't it incorporated into everything that we do for drill and blast? And I think generally that teams want to improve. You may already, again, people in this audience may already be partially doing most of or some of this digitization of drill and blast field data, but I think generally people want to know where to start. So again, the question is, how do we have time? I think that it really is down to the right digital technology, making it easy to communicate our plans to the field and vice versa. What you see there on the screen is a couple of screenshots from our system called Datablast, which is on the left, the Datablast system desktop software. On our right-hand side is our BlastPad application, which is a tablet application that our field users would use. What makes digital technology easy in the context of drill and blast field implementation and digitizing the data coming back is that with technologies like this, all you need to do in everything that I described before is set a flag, let the network take over to communicate the designs, and it'll be ready for your operators. It's as simple as that. So let's have a quick chat about sort of the technologies that we see in the drill and blast industry for this field data. Tablets is obviously the thing that is going to be a simple first step for a lot of people in that journey to digitization. With our software, BlastPad, it can help you with help your operation collect data on specific areas in the process, like your drilling, QA/QC, your charging. If you do backfilling as a dedicated campaign, you could use it for backfilling and priming. So something that you can use to collect lost primers if that unfortunate scenario happens. So the general advice I think I would give is when selecting a tablet system, make sure it doesn't give you more work than and is integrated to your designing and checking process. You don't want a separate system that actually causes you more work in your space, but only alleviates it for your field operators. It should definitely be something that helps engineers and field operators. Also consider that, mostly the software's on tablets is mostly going to be used by field operators in very harsh environments. Hot, dusty, depending on whether you're a driller or QA/QC or a charge crew. It needs to be easy to use because they've already got a lot of things to concentrate on. It can't be something that is what we're used to as engineers is, we're happy with buttons, we're happy with lots of features. We've got the time to sit at a computer and, amongst all our production pressures, we can still use it. But for a field operator, there is no margin of error. They need to have something simple to use. In other ways that we can digitize field data and the technologies involved, often we talk about integration and automation as well. So specifically about drilling is one topic that we can discuss here. The best method of digitizing drilling data, in my opinion, is to use a drill navigation system. It can be obviously cost prohibitive for some operations, and if you're able to use it, then fantastic. There's several fleet management system vendors out there in the industry that provide great drill navigation systems to automate your design implementation so that for example, your surveyors don't have to go out and mark out holes for drilling anymore. And collecting that data back, including things like GPS positions, timestamps, operator names, drill depths, MWD, measure while drilling, just to name a few. These automated systems definitely do help you with collecting a lot of automated data collection. Drills themselves are manually operated, but definitely a lot of information that can be gained. So, as a quick snapshot, how can we make use of this data? Well, for us, and in my opinion, hole positions and depth can ultimately affect things like energy distributions and blast contours. We definitely want to see that immediately. Datablast has inbuilt automation features to import drilling data and use it immediately. And then automatically updating charge designs gives you a lot of peace of mind because, whether a hole is shorter or longer, that the calculations are working in the background for you. Just further on this, the technologies that support the journey to digitizing your drill and blast field data on the tablet devices themselves and how that can actually be incorporated into your site operation. There are a lot of devices available in the market, so there's no sense in I guess suggesting specific ones. But do consider this. Consider that obviously it meets the software requirements for the tablet that you're choosing, should meet the software requirements of the product that you want to run. And the second one is think about the accessories that are available for that device. So these tablet devices need to live in charge trucks and drill machines and in the hands of QA/QC operators in the hot sun. So think about the accessories to help charge, docking stations if possible for vehicles, sun protection so that it makes it easier for operators to see the screen in the sunlight. Not fall protection, I mean drop protection, and maybe even waterproofing. You never know, it slips out your hand, falls into a puddle of water, and you don't want that device to be destroyed so quickly. On the topic of network, an integrated drill and blast tablet technology should really allow you to have immediate synchronization within your own sort of network range. And there is a big topic of discussion here in itself. How frequently do you need your field data to be synchronized? Well, it's completely up to the operation, right? And it can chop and change. On the right-hand side, we see I've just drawn a couple of schematics to explain this story. The top right, this is where you may have wireless network coverage zone just around or in your office. So nothing in the pit. What that means is that your devices would need to be brought back to access point at the start and end of the shift so that you can synchronize designs and data coming back. It could fit your operation, definitely, because perhaps you don't change that often and you only have maybe one or two drill machines that you want to digitize but don't need to have such a heavy dependence on 24/7 data capture. On the bottom side is, well, some operations do obviously have various access points and repeaters around their pit operations. So what that's going to mean for you on this journey is, well, utilizing drill and blast technology for digitization. If you had wireless coverage extended to the pit, you could expect more frequent synchronization, even instantaneously, and it means you can make much more quick production decisions on the fly. And where do we start? With all this stuff, there's a lot to talk about, but where do we start? My suggestion would be, operations don't have to implement technology straight away into every part of the drill and blast process. This takes time and training. So to begin, I would suggest start where your worst drill and blast problems are. For example, if you do have some occurrences of fly rock, make sure you do have that robust design and checking process, but strengthen it by checking the conformance of your drill hole positions and charging positions as well, collected by a collection of survey or GPS or tablets to collect charge information, if it's as crucial to you as it is. Now, what about uneven running surfaces? So if this is a particular example that you're trying to tackle, maybe utilizing more technology to help gather your blast hole depth conformance, so that just like the example I gave before, we could analyze it and see that there was no way that the blast surface was going to be even, but incorporating that technology so that you could make that and see that problem in advance is going to be crucial. Cost controlling, if that's something that is a crucial measure for you to solve and get on top of, just make sure that we're checking the design versus loaded explosives per hole. Again, I might have touched on this before, but if your design for a particular blast pattern is 100 ton of explosives, and you do collect information from the charge trucks to say that they loaded 120 tons, at the very least, you know that it's beyond your design cost, but it's not going to tell you very much for why. Why is that the situation? So having some ability to collect the information on a hole-by-hole basis is going to uncover really quickly for you where and why you're overloading or underloading. All in all, I think whatever the problems are, however, wherever in the journey to digitization for field data you are in, I think we really do need the right tools. That's paramount in my opinion. With so much data that's been collected either from drilling or QA/QC or charging, it's really important that we don't just replicate what the paper system does, which is just have a whole stack of information everywhere. I think it's really important to centralize it. So this is a few words to describe what Datablast system can offer and help you guys with in your operations. Datablast is built on a centralized data storage. All your designs, all your data that's collected, it's in one place. It's easy to access. You can avoid mistakes. With all the information that you have, you want to make quick production decisions, even design change decisions. So for that purpose, you need to have drill and blast tools actually dedicated for you as a drill and blast engineer. Field data capture we've covered, and integration automation is something we covered. Moving into that sort of digital world with drill and blast also means to integrate data into a central system. As I touched on before, if you've got a drill navigation system with so much information there that is just not touched and not even looked at in terms of how it compares your design, it's not that valuable, or sorry, it is valuable, but there's a lot of value that hasn't been extracted yet. So think about that idea. And lastly, there's the concept of obviously making your reporting and analytics more easy, and I can touch on that a little bit later on. So now I would like to show you a quick demonstration of how BlastPad and Datablast operate with each other to help our customers with collecting drill and blast field data. Actually, it's a very quick demonstration because it is a simple process. So let's start off with our Datablast. This is our desktop software. And at the same time, what I'm doing at the moment, just for this demo purposes, I'm also going to be running our BlastPad application just on this desktop. Let's start off with the first activity we might want to do, which is drilling. The operator that's using the tablet in the drill machine would be able to select what machine they are, who they are, and perform a login process so that there is security behind the data. And they'll be able to select all the available patterns. At the moment, I can see that the pattern that I want to drill is not quite ready. So this is where we're mixing what happens in the office versus what happens in the field. As an engineer, I have designed my pattern. I'm happy with this pattern. This is what I need to do to blast the next block, and it's ready to go. So just like I showed you in those screenshots before, the process is actually fairly quick. I just need to make this live. That's one of the mechanisms. We have some other mechanisms to make the synchronization quite automatic. And then we would come into our BlastPad and it would just immediately pop up as long as you have a network connection, right? The operator would be able to just select, because he knows from his shift start meeting the pattern he's meant to be going to, and he'll be able to select it from a list of available active patterns. And as soon as he does select it, he can load it up and see what he needs to do. How this now helps your operators with this digitization journey is they know which holes they need to drill. Maybe this is still a mixture of surveyors going out to mark out patterns. This is not a GPS system in any sense. So it's going to definitely help you with digitizing your drill log data, which often is drill depths and similar facts of your drill hole. So the operator will go up to the hole that he needs to drill. These orange icons help the operator see which holes need his attention or her attention. So by selecting the hole, you'll be able to do things like, all right, the moment you start drilling the hole, you can simulate the start time. This will help you with collecting information like your, or with your start and end time, you'll be able to see your potential penetration rate. It's not going to be as accurate as what can be offered by things like drill navigation systems. But again, on this journey to digitization, it's multiple steps. It's a journey, right? So the operator would complete his hole and touch on the button here to record the drill log depth. Let's say that the operator drilled 22 meters. And for the moment, I won't record anything else, but perhaps I'll just flag the fact that I did encounter a bit of broken ground. So that's done. So what does that mean now in Datablast? Well, what this demonstration is doing at the moment is showing you the actual reality of what would be happening in the field. The data is synchronized back to a server. The server is processing the data for our engineers. And if you have the pattern loaded, you can hit the refresh button and you'll see that whole data, whole status change. So drilling, this is the digitization process. I can select on the hole. I can see which drill machine was attending the hole, who the operator was, what day, start time, end time, and of course, because I drilled it so fast in 30 seconds, it's a very unreasonable penetration rate, and more importantly, the drill depth, 22 meters. So the process, very simple. You got to obviously consider some of the topics I discussed before, which is your network capability and how frequently that data can synchronize back. But if you did have that constant network connection, there it is. Now let's move on to the next process in the drill and blast. The drill and blast process. This next step in the drill and blast process. Now imagine that this tablet is in the hand of, or a secondary tablet is in the hand of a QA/QC or blast crew. You'll be measuring the holes. Automatically, the data has synchronized. So for the blast crew operators that need to measure the holes, they can see in this sea of white holes that are still in a design condition that there is drill data against 212. It's turned blue. I'm the operator. I can see, oh, there's the orange icon. I need to go and perform some measurement of this hole. So again, you would perform whatever you need to do. Measuring the depth of hole is one example. Perhaps you also encountered some water in the hole. And you also do see that the drill operator told you it was broken ground. Great. Save that. And here is the data collected on the tablet. Same situation. Now you're the engineer back in the office waiting and for the data to synchronize. Again, if you've got the pattern loaded, you can hit the refresh button. Oh, wait for it to come back. And if I select on the hole, I can now see there's measurement information about the hole too. So again, a timestamp of when it was entered. The depth that it currently is now is 21.5, not 22, it's fallen in a bit, and that there was some amount of water in it. That's good. So the measurement and the QA/QC process, again, also fairly simplistic and easy for operators to use. Now, let's cast our mind to the next process again, which is your charging. So this tablet device now sits in the hand of, or another tablet device sits in the hand of your MPU operator, for example. And they would log in, same idea. They will see the pattern, they will see which holes need attention. So if the holes have been measured with QA/QC, it's now ready for loading. So as the operator, I can select on the hole and see the explosive requirements that's needed in that hole. Now, there's some other concepts here that I can quickly explain. So based on the design of these, of this particular charge pattern, it's saying to me that I need ANFO for the hole.
Alfred, sorry to interrupt. We just got a question in this area about the tab design. So how to plan depths, especially related intersects with coal seam model. That's the question from Rio or Ryo. Sorry for the name.
Okay, no worries. Rio, I might catch up with you after this session and I'll show you specifically what that, how the coal intersections work with Datablast and BlastPad. Unfortunately, I don't have that data set up for this demo, but I can definitely show you. So yes, let's to continue on. One of the concepts I wanted to explain about Datablast is it's not a static thing. So if you do have updated information and designs that need to be updated by the engineer, you could make a decision to say, well, actually, I can see there's a bit of hard material at the bottom of some of these holes based on the face profile, things like that. And so you might want to change your charge designs. So the synchronization to BlastPad and in this context of digitization, it can't be static. It needs to be able to update for you. So as a charging engineer or blasting engineer, I might come into here and say, well, I actually do need some emulsion-based product at the bottom of the hole. So I can update my design. Perhaps I need 3 meters worth of the emulsion blend. And I save that and return. Datablast will update my charging design requirements, and then it'll be ready for BlastPad to synchronize. So we'll give it a moment to register that it is a change in design. And then we can look at the hole. So in that same hole, which was full ANFO before, a change of design has updated my requirement in the field tablet application as well. So again, when we're talking about digitization, quick, streamlined, easy for operators, easy for engineers. This is the story that we need to go. And of course, just to show you, if you are the load operator, you would load explosives into a hole. And coming back to our Datablast system, the engineers would be able to check after it synchronizes. Which hole did I load? 187. If I view that hole in the desktop, I can now see, yep, this amount of explosives in that deck was loaded by this machine, this operator, this timestamp, and this is the quantity of explosives that was put in. So you're going to immediately see all these facets of your drilling and blasting that is much more detailed than before, but it's definitely quicker and easier than to issue paper, record it, type it down, do data entry, and reanalyze it in different software packages. That is the power of having a good digitization process. So to come back to my presentation, what do we now do? We've got all this data. This is a topic I'd like to say for a next webinar. So if people are interested, definitely let me know. But it's on the topic of reporting and reconciliation. Of course, for Datablast in our system, everything is collected into one place, as I mentioned before. Everything will then obviously be available for us to have automated reconciliation reports. And the idea is that it doesn't just tell you total metrics, it also can, through the insights and the data that you analyze, can tell you areas for improvements. So yeah, thanks for your time. That was a very quick 40 minutes. I went over a little bit over time, but it was great to speak to everybody. So yes, Rio, please, we'll get back to you and I'll share with some proper data sets to understand what coal intersections would do with Datablast. Did we have other questions, Katarina?
Not yet, but I'll give a couple of minutes to guys if anyone would like to type in their questions so we can address them, because I think we still have a couple of minutes left for the webinar. So if you guys have anything, please type in now, and I'm pretty sure Alfred will be happy to address them. Here's a question from Yash again. Can we track the blasted rock?
Sorry, what do you mean by tracking the blasted rock? As in the total, like the production data, as in tracking material from data, the blasting stage to perhaps dumps or grinding circuits? Is that what you mean?
Do you want me to unmute Yash so he can voice it?
Yeah.
Yeah.
Well, let me take a stab at answering the question for you there, Yash. If we're talking about tracking blasted rock, within the Datablast system is where you're going to be able to understand what the procedures were to blast the rock. Within Datamine, our portfolio of software allows you to do exactly that. So it could be that if you want to track production loads from mining locations to dumping locations, we definitely have a tool there to help you. Again, I'll reach out to you on that topic. If you're interested in tracking material and blasted rock through a grinding circuit or tracking that material through a plant and through to the stockpiles, we have products for that as well. So definitely I'll reach out.
Okay, thank you.
Thank
Hi,
you,
Omid.
And we've got...
Share the presentation, of course. Yep, so this webinar was recorded. We will make this available to everyone who's registered. All right, it doesn't look like there's many more questions. Again, please, everybody, if you do actually have questions you don't feel like putting into this chat box, please write send me an email, get in touch. I'm more than happy to answer them. Everyone who did ask a question will definitely come back to you to quickly answer your
Alfred,
question.
you want me to?
Yeah, I
got just now
that.
another one.
Yeah. Is software able to predict the vibration and fragmentation? Definitely. Let's do. It can definitely do that. Just in the interest of time, Shishil, I'll also reach out to you and show you. I might share some content with you to show that idea. Or I can organize with you to give you a one-on-one demonstration as well. Datablast definitely can help you with understanding vibration prediction and your fragmentation prediction.
All right, I think we need to close because we're getting a little bit over time. And as Alfred said, like if you have any questions, please feel free to email Alfred and he will be in touch with you.
All right. Thanks for the question, everybody. It's really good to have some engagement here. So thanks, Katerina.
Thank you, Alfred, and thank you everyone for attending, and have a lovely day.
Yes, good day.